Hello friends, welcome back to another machine learning model, that is medical insurance cost estimation using Lasso Regression. So here we will implement Lasso Regression to estimate the health insurance cost in medical. So before implementing how much it cost, we will go to Notepad to discuss about the lasso and its advantages and disadvantages. So first of all, let me write it lasso, and the full form of lasso is that least absolute shrinkage and selection operator. What? Least absolute shrinkage and selection operator. So this is the full form of lasso. So lasso is a regression technique used in statistics and machine learning to perform both variable selection and regularization. It is a variant of linear regression where we add L1 regularization. The prerequisite for lasso is linear regression because it is a variant of linear regression. Now we will calculate the error function for lasso regression, and it is nothing but the mean square error of linear regression with L1 regularization. So let me write mean square error, that is MSC, of linear regression. Then we will add L1 regularization to it, that is nothing but lambda times mod of beta 1 plus mod of beta 2 plus dot 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 plus mod of beta n. So we will take mod of all coefficients, then we will add them, and finally we will multiply with lambda, and that value will be added with the mean square error of linear regression, which will act as a penalty. So here lambda is nothing but a positive value, which is also called regularization parameter. As we don't have beta, therefore we are writing B for beta. So please understand, B for beta. So betas are nothing but the coefficients of features or variables. So lambda is a positive value which should be always greater than or equal to 0, and it should not be a negative value. It is also called regularization parameter. This regularization is also called L1 regularization, that is nothing but the sum of mod values of coefficients times lambda. After this, we will discuss about advantages of lasso regression. The first advantage is that it has the capability to select features. So when some coefficients are not so relevant or important, it makes that to 0, and when they are relevant and important, then there becomes some value, that is non-zero value. So it automatically sets some coefficients to 0, effectively selecting a subset of important features. This is the first advantage. Let me write that. After this, we will discuss about second advantage, that is the results produced by the model is very simple to understand and easy to interpret. That's why we can write it is simple and interpretable. So let me write that. The third advantage of lasso regression is that it can handle multi-collinearity. So as it selects one of the correlated features and discards the others, by that procedure it can handle multi-collinearity. And the fourth advantage of lasso is it is very much useful in high dimensional data, because when the number of feature exceeds the number of observations, that time it will select only the relevant and important features from the dimensions. So that's a very much important advantage of this lasso regression. That's what I am writing now. Particularly reduces the number of features which are irrelevant for model building. After this, we will discuss about disadvantages of lasso regression. So particularly we have three prime disadvantages. The first one is bias in coefficients. That's nothing but when the coefficients of variables are made to shrink towards 0, that can introduce bias in estimation. So it may result in bias in coefficients. After first disadvantage, the second disadvantage is it has lasso regression has selection instability, because when there occurs a small change in data, the model selects different features. So for a minute change also the model selects different features. That's why it has feature selection instability, which is a very big disadvantage. After the second disadvantage, the third disadvantage is that the lasso regression cannot handle groups of correlated features well, because it picks only one feature from a group of correlated feature and ignores remaining, which may have some important values. That's why this is a very bad at groups of correlated features, and it is unable to handle the groups of correlated features. It only picking one feature among all the features. This is what the lasso regression is, where we will have L1 regularization, that is called lasso regression. It's very simple. And now let's move to Kaggle notebook, where we will implement the model, and we will also implement health insurance cost by the medical with this lasso regression. So for that we will import all the required libraries like pandas, numpy, matplotlib, seaborn, joblib and scikit-learn. The pandas is used to manipulate data frame. The numpy is for numerical calculations, Matplotlib and Seaborn are for data visualization. Joblib is to shape the model. And from scikit-learn we will import different methods and classes like train test split, column transformer, pipeline, lasso, standard scalar, min max scalar, one hot encoder and ordinal encoder. So the train test split is located at model selection module, and this will be used to split the data into train section and test section. So during model training we will use train section, and during model evaluation we will use test section. After that we have imported column transformer to pre-process all the columns simultaneously only once for SAC. After that we are using pipeline, and pipeline is for building pipeline between transformer and the model. Then we are importing lasso for building the lasso model, and the remaining preprocessor I will discuss when it is needed. So after that we will prepare the data. I am adding medical underscore cost.csv file from Kaggle in my input using the add input button. So if you have any other files you can also upload, and after uploading go to the directory, then click on the file and copy that path and paste over the read CSV method, which will read the data available in the CSV file and returns a data frame. After that we will show the first 3 rows of the data frame using the head method. So you can see we got 3 rows where we have columns like age, sex, BMI, children, smoker, region and medical cost. The medical cost is our target variable, that is our insurance cost. So that's the model will predict. After that we will do some steps like removal of duplicates and removal of nulls if they are present. So to remove duplicates we have drop duplicates method, where we have passed 2 arguments, that is in place equal to true and ignore index equal to true. When we pass in place equal to true, the original data frame will be changed, and when we pass ignore index equal to true, the order of the index will be reordered. Then for the drop NA case, it is for dropping the null values if they are present. The same arguments are again repeated so that the original data frame will be changed and the data frame will be reordered. After that we are checking the information of the data frame with info method. So let's check the information. So here we go, you can see we have total 7 columns including the medical cost or health insurance cost, where we have 10,000 entries and their range index is from 0 to 9,999, and we have the list of column names and their non-null count and their D types, and you can see we have 2 float 64 columns, 2 int 64 columns and 3 object type columns. After that we will go for exploratory data analysis, where we will plot the categorical columns. So first of all we are selecting the categorical columns using select D type method, where we have passed include equal to object, and when we use attribute columns to that, it will return the list of columns. So the whole line will return as the categorical column names. After that, creating 3 subplots where there is 1 row and 3 columns. Figure size is 10, 3, that means 10 pixel to 3 pixels. After that, we are adjusting subplots in such a way that the space between 2 plots is 0.3 pixel. So subplots underscore adjust method is used to do that. After that, we are iterating over the categorical columns, and the categorical columns will be plotted through count plot. Count plot is available in Seaborn library, and for each column in the categorical columns list we will select a subplot. So that's what the first line under the loop, that is plt.subplot, where 1, 3, I plus 1 indicates row, column and the plot number. Inside the count plot method we have 2 arguments, x equals to col, that is the column name, and data equals to df. So data will be retrieved from data frame. After that, we have another method plt.xticks, that is for xticks. That's nothing but the names of the column or the values inside the column which are rotated to 30 degree. So after that, let's show our model with plt.show. So sorry for the disturbance, a call came. I am showing that. So here you go. We have sex column, smoker column, region column, where we have male and female in sex with the same number of distributions. Then in smoker we have yes and no with same number of distributions again. Then in region we have northwest, northeast, southeast, southwest with the same distribution nearly. After that, we will split our data into train and test. So to split, we will take out the features and target. So that's what we have done. X will take out only features, Y is the target. And after that, using train test split method to split into 2 sections, train section and test section, where we have passed 2 more arguments, that is test size equal to 0.2, that means 20% of the data will be reserved for test section. And then we have random state equals to 42, that is for regenerating the same result when the notebook is re-executed. Then that splits will be saved in xtrain, xtest, ytrain and ytest. Xtrain and xtest will contain features, ytrain and ytest will contain targets. So let's see the shapes of xtrain and ytrain. So it should return same number of rows. So you can see 8000 rows in xtrain and 8000 rows in ytrain. So let's move on and pre-process data. To pre-process, we are using column transformer, which will take 3 arguments: transformers, reminder and sparse threshold. So transformer will take a list of tuples, and remainder will take pass through and drop. Then sparse threshold will take a value between 0 to 1. So transformers argument is list of tuples. So in each tuple we will have the identifier for the instance of the preprocessor. Then the second value in the tuple is instance of the preprocessor. Then the list of columns to which that should be applied, the pre-processing should be applied. So remainder will take two arguments, one is pass through, another is drop. When we pass drop, it will drop the remaining columns which are not mentioned in the transformers, and if it is pass through, then it will return all the columns even if they are not pre-processed. And sparse threshold value should be between 0 and 1. When we specify 0, the sparseness of the result given by the column transformer is 0, and if it is 1, then we will get a sparse output. Now I told that I will explain about standard scaler, min max scaler. So standard scaler will convert the numerical values between -1 to 1, and min max scaler will convert the values into minimum value of the column to the maximum value of the column. Then one hot encoder and ordinal encoder. So whenever you are using categorical columns to pre-process these preprocessors, so one thing you should notice that if the data is nominal, that means we can specify some ranks to the categorical values like no and yes. We can assign 0 rank to no and we can assign 1 rank to yes, but we can't assign any rank to male and female because they both are equal in sex. When we can assign a rank, that type of categorical data is called ordinal data. When we can't assign any rank, that type of categorical data is called nominal data. So for nominal data, use one hot encoder, and for ordinal data, use ordinal encoder. Then inside the one hot encoder, I have specified 3 arguments: drop, handle unknown, and sparse output. Sparse output is to whether the one hot encoder returns sparse data or not. So false means it won't return sparse output. Handle unknown is to ignore out the unknown values, and that's what the pre-processing step. After that we will build our model. So we will build pipeline. Pipeline will take one argument steps, that is a list of tuple. Inside each tuple we need to specify 2 values. One is the identifier of instance and another is the instance. So we are using a preprocessor and a model in pipeline. Oh no, when we run it we got an error because we have not run this preprocessor column transformer. You can see we have standard scaler, min max scaler, one hot encoder and ordinal encoder in preprocessor. Now we have preprocessor and the lasso model in pipeline. So preprocessor have the standard scaler, min max scaler, one hot encoder and ordinal encoder along with pass through, while lasso is added to that in pipeline. After that we will train our model with the method fit. So to train we will use the train section data The train section data is nothing but X train, Y train. X train contains the features, Y train contains the target. So here error will be calculated and beta values will be adjusted. So model is trained successfully. After that we will evaluate our model with accuracy. So to do the performance calculation, we have a default method score, where we need to pass the test section data, that is X test and Y test. X test contains features, Y test contains targets. So it will return as the accuracy. So let's run that and let's see what is the accuracy or what is the performance on test data by our model. You can see it has returned 0.99. that means 99% accurate is our model in prediction. So our model is performing superb, outstanding. After that we will save our model with joblib library, in which we get dump method. The dump method will take two arguments. One is model instance, another is the name of the file where we want to save the model. So I am using insurance underscore cost underscore estimator dot joblib as the file name. After saving that, we will save our cleaned data. So let's save our data also. So in the pandas we have a method to underscore csv. Generally this method is used to save the data frame. So I am saving in the file name called insurance underscore cost underscore estimating underscore data dot csv. This file will have the cleaned data. So after this, saving both trained model and the clean data, we will go to the output section and click on the working directory to get these files as downloadable. So to download these files, click on the three dots available, and that will show us a download button. By clicking on that, you can download the trained model, the cleaned data. So with this, our model is built successfully. So download, and let's build the interface for our model. So we will now go to the VS Code editor to build the interface for this model. We have developed our model with scikit-learn, and we will develop our interface with Streamlit. So let's import the required libraries like Streamlit, pandas, numpy and joblib. Streamlit is for building the interface, pandas is for data manipulation, but here we will just load the CSV file. The numpy is for numerical calculations, but here we will cast the text data to either integer or float. Then to load the model we are using joblib. So make sure that you have downloaded your files in where this app.py is located, so that easily you can load your model. So as we have downloaded this insurance underscore cost dot estimator dot joblib in the same location as app.py, and the same data.csv is also located in the same directory, that is Lasso Regression, including another images that I will use in this interface to look that cool. So Lasso Regression is my directory where I have these files, So I am loading the model in the variable model and loading the data in the variable df. After that we will create a container. So it is the initial part of the interface where we are showing an image as a title to the interface or the model. So this image will be shown with the container width, and to keep the image in center we are using 3 columns. Among the 3 columns we will use the second column so that the image will be in middle. After that we are creating a container for inputs. So under the container we will create 6 columns, 2 rows and 3 columns. Will keep 6 columns. Yes or no? Yes. So under each column we will have one input field. So 1 column for 1 input field. So here you can see under the column 1 we have age, where we are taking text input from the user, and we have the age as label. Then placeholder is the minimum value to maximum value, and the default value is the minimum value of the column itself. And whenever the user enters the value, it is in string format. So as when we trained our model, we have given or we fed the model with integer format. So we need to convert the age into integer format. That's what I have done. Then under the second column we have gender, that is sex in column names, but I am mentioning gender. So here options are unique values of the sex column, and to show that we are using select box, and the user entered value will be saved in gender. But this should not be converted to any other data type because it is trained with original string format. After that under column 3 we have BMI. We are taking the user input with text input method, and we have the placeholder minimum to maximum. Then the default value is the minimum value of the column. Then we are converting the BMI to float 64 if the value is entered. Similarly, for number of childrens we are going with column 4. Here we have a select box to show the number of childrens, and in options we have the unique values in the children's column, and that is also sorted. So we get 0 to 5, 0, 1, 2, 3, 4 and 5. But as the model is trained with integer data, so we are casting the user selected value to integer format. After that we have column 5, under which we are going for smoker column. So here also we are using a select box, and we are approach with same as other categorical columns, and for region also we have the same approach as other categorical columns. Then for outputs we have a container. So under that we need a data for prediction, and the data is entered by the users. So the main important part of this is to create the good formatted data frame. So this is what very much important. If you miss it, you will face troubles and errors. Definitely, I am sure, because I have faced lots of problems and errors when I built this data frame. So we should pass a dictionary to build the data frame, and inside the dictionary the keys should be the names of the columns of the data frame, and the user entered value should be in list. After that, using the model.predict to predict the data. Then under that we have a container with border, and then we have 3 columns to keep the output in the middle, and we have vertical alignment equal to center, so that the data that we represent should be in the vertical position or center of the vertical position. So under column 2 we are just showing insurance cost and the predicted value rupees only in rainbow color. To run this file, open the terminal. So to open the terminal in VS Code editor, press Ctrl Tilde. So after opening the terminal, write streamlit run and the name of the file, that is in my case app.py, and if you have anything else, write yours. Then press enter, which will open the default browser. So it may take some time. So yeah, it came. So we have health insurance. So you can see we have these default values and the default insurance cost. So the default cost is 15,869 when the smoker is yes. The smoker has greater impact. I saw it many times. So you can see age is minimum is 18 and maximum is 65, because we have the placeholder minimum to maximum. Similarly, other columns also show the minimum to maximum. Notice that when I changed the age value to 30, it has changed to 16,467, and when I changed the gender to female, it changed to 16,472. So this is the way the model predicts when the different value we enter to it. So I am entering BMI equals to 25. Now you can see the insurance cost prediction is 16,756. After when we add the number of children's count is 3, it becomes 17,360. And when the smoker is no, as I told, smoker has greater impact, so it will reduce to a very less amount. I hope so, around 5,363. And the reason will not give any impact, because based on reason no medical will give insurance to peoples, so reasons do not have impacts. So thank you very much who has watched completely my video. Thanks a lot. Have a great life and great future. Thanks very much.